Hello everyone. So today we will study the final session in this statistics and industry and commerce, which is to understand the use of statistics in quality control. So in this session, we will cover defining uh, quality control and quality assurance. And we will also look into a range of statistical techniques used for quality control and improvement. Then we will explain using examples how the following quality techniques are applied in business context. So this will relate to Pareto analysis, statistical process control, capability charts, and acceptance sampling. So these are the main topics that we will cover in today's session. So the first one to start with is defining quality control, and quality assurance. So basically to understand the difference between these three terms. So the first thing is quality. So quality, it refers to the degree of excellence or superiority of a product, service, or process. So how superior is the product based on certain quality parameters, which meets or exceeds the customer expectations and specifications. So it encompasses various characteristics such as performance, reliability, durability, and aesthetics. So it can be, quality can be measured in various parameters. For example, customer satisfaction. So how satisfied are customers with the products? And then quality, performance of the product. For example, if you have purchased an iPhone, what is its performance? Then reliability. Can you rely on an iPhone to perform after it gets wet in the rain? So there has to be certain quality parameters with respect to that. So that is how we look into it. And then, so quality is subjective and can vary based on customer needs and preferences. But certain quality parameters are defined. For example, if a product says it meets the ISO, say 14,000 parameters, so those are well defined. But in general, the quality in from the customer's perspective is subjective. So then next we look into quality control. So quality control, it involves the processes and activities implemented to ensure that products or services meet predefined quality standards. So again, this is a comparison, or basically benchmarking with the quality standards. So it focuses on detecting or correcting defects or deviations from specifications during production or delivery. So then quality control activities, it include inspection, testing, and monitoring of processes to maintain consistency and reliability in the final output. So that is the basic understanding with respect to the quality control. So always remember, quality control is with respect to the defined parameters or benchmarks of quality. Then the third one is quality assurance. So quality assurance, it encompasses the systematic and planned activities which are implemented to ensure that processes are designed, implemented, and executed effectively to meet quality objectives. So quality assurance, it basically refers to the process that that involves the quality parameters and quality assurance. So it aims to prevent defects from occurring by establishing standards, procedures, and guidelines for quality management throughout the organization. So like I said, it could be adherence to certain quality standards such as ISO standards, or it could be BS 7799 standards in services. So these are the various quality standards. Then it emphasizes continuous improvement, training, and adherence to best practices to enhance overall quality performance. So these are quality assurance parameters. So basically, to summarize, quality, it represents excellence in products and services, whereas quality control, it focuses on identifying and correcting deviations from quality standards during production or delivery. And then quality assurance, it refers to the processes, a process-oriented system, which ensures that processes are designed and executed effectively to prevent defects and maintain consistent quality levels. So both quality control and quality assurance are essential components of quality management system, and they are aimed at achieving customer satisfaction and organizational success. So basically, quality parameters, they are aimed for meeting the benchmarks or exceeding the quality of the products that are already there in the market. So, and the ultimate goal obviously is to enhance customer satisfaction and contribute towards organizational success in terms of profitability. So next, we look into a range of statistical techniques uh, used for quality control and improvement. So there are some certain statistical techniques which are used for quality control and improvement. So the first one is control charts. So the control charts, they monitor process variation over time, distinguishing between common cause, natural, and special cause, which is variations. For example, examples include X bar and R charts for monitoring process means and ranges. So control charts are one way of assessing the quality control and making improvements. Then we have histograms. So histograms, it displays the distribution of a process characteristic, aiding in understanding variability and identifying potential issues such as non-normality or outliers. So, histogram, in a sense, in quality management system, it is basically used for identifying outliers. Then we have Pareto analysis. So Pareto analysis, it prioritizes the problems or causes based on their frequency or impact. So it and allowing focus on most significant issues for improvement. So there is also a general Pareto rule which says 80-20, like 80% of the problems is caused by 20% of the defects. So then we have root cause analysis. So it includes it identifies underlying causes or causes of problems or defects, often using technique like 5 whys or Ishikawa fishbone diagrams. Then we have designs of experiments. So systematically, so this include this is the concept which systematically varies factors to identify the effects on a process output, thereby enabling optimization and robustness improvement. So this is the concept of design of experiment. And then we have statistical process control. So this utilizes control charts and other statistical methods to monitor and control processes, ensuring they remain stable and predictable. Then the next statistical technique is capability analysis. So it assesses process capability to meet customer specifications, typically using metrics like CP, CPK, PP, and PPK. So these are different metrics. So then we have regression analysis. So regression analysis, it identifies relationship between process variables and outcomes, which aid in understanding and predicting process behavior. So then we have failure mode and effects analysis. So it proactively identifies potential failure modes. So what could be the failure mode of, say, one of the aircraft component? So it will different types of stress tests will be conducted and the failure modes will be identified. And then the causes and effects, thereby allowing preventive actions to be taken. Then you have Six Sigma tools. So this includes methodologies such as DBAC, which is define, measure, analyze, improve, control. Then you have statistical tests and tools such as ANOVA and hypothesis testing. Then you have reliability analysis. So this technique evaluates product or process reliability and durability using methods like variable analysis, reliability modeling, and survival analysis. Then we have sampling techniques. So sampling techniques, this is employed for efficient data collection and analysis, which includes random sampling, stratified sampling, and acceptance sampling plans. So these are the techniques that are used for quality control and improvement. Then, so to conclude, by applying these statistical techniques, organizations can effectively monitor, analyze, and improve processes, which leads to enhanced quality, increased customer satisfaction, and reduced costs. So each technique offers unique insights and benefits. So again, not all the each of the technique may not be suitable for all the scenarios. So they are suitable for some specific scenarios. For example, some techniques may be suited for manufacturing context. Some technique may be suited for industrial context, and some techniques may be suitable for services. So each technique offers unique insights and benefits, thereby contributing to overall quality control and improvement efforts. So next we look into the different quality techniques and how they are applied in business context. So for this, we will be looking into Pareto analysis, statistical process control, capability charts, and acceptance sampling. So the first one is Pareto analysis. So in a manufacturing company, Pareto analysis could be applied to identify the most frequent types of defects in a production line. So suppose analysis reveals that 80% of defects originate from 20% of causes. So the company can then prioritize efforts to address these critical causes first, such as implementing preventive maintenance on machinery which are prone to causing defects. So again, this Pareto rule is very common, which involves 80-20, and it is used in various contexts. Then you have statistical process control. So a food processing plant monitors the weight of packaged products using control charts. And so if the weight deviates beyond control limits, indicating a special cause variation, then immediate corrective action is taken. For example, you can have potato chips. So the normal is say 100 grams. So if the deviation goes to 20 and there is a limit of plus minus 3%. But if the limit goes beyond, for example, if a packet weighs 90 grams, then that is outside the control limit. So again, immediate corrective action is taken. For example, adjustments are made to the packaging machinery to ensure consistency in product weights within acceptable tolerances. So then we have capability charts. So an example is an automotive manufacturer uses capability charts to assess the capability of its assembly line to produce components within specified tolerances. So if the capability analysis reveals that certain processes have CP and CPK values below the desired thresholds, such as for engine cylinders, then the company invests in process improvements or equipment upgrades to enhance capability and reduce variation. So this is how capability charts are used. Then you have acceptance sampling. So the example is a pharmaceutical company performs acceptance sampling on batches of medication to ensure product quality before release. So for example, random samples from a batch are tested for purity and potency. So if a sample meets predefined acceptance criteria, then the entire batch is accepted. Otherwise, corrective actions are initiated, such as retesting the batch or rejection of the batch. So as you can understand, each of these industries can have potential and significant implications if the control limits are not maintained. So therefore, there is a lot of focus on quality management in organizations. So in essence, these techniques enable businesses to systematically identify, monitor, and improve quality aspects, ensuring products or services they meet the customer expectations and regulatory requirements while minimizing waste and defects. So now we look into the distinction criteria, which is to compare and use of SPC control charts and capability charts in business. So to compare the use of SPC control charts and capability charts in business, it is essential to understand the respective purposes principles and applications within quality management. So statistical process control charts. So these are tools which are used in quality management to monitor and control processes. They are based on statistical principles and help in detecting variations and deviations in processes over time. So the purpose of SPC is that it is used to monitor process performance over time by plotting process data points on a chart. So the aim is to distinguish between common cause variation, which is inherent to the process, and special cause variation, which is due to external factors. So in terms of principles, the SPC control charts are based on statistical principles, particularly those related to variation analysis. So commonly used control charts include the X bar chart, R charts, and individual I charts. So these charts are help in identifying when a process is stable or when it exhibits special cause variation, which requires investigation and corrective action. Then application of SPC. So SPC is generally used in manufacturing and service industries to ensure consistent quality and identify opportunities for process improvement. So for example, in manufacturing, SPC control charts can monitor variables such as dimensions, weights, or chemical concentration. So in service industry, they can use to measure the response time, the error rates, or customer satisfaction score. So for example, response time to, for example, if your internet broadband is not working, so what is the response time of the service center of the organization? So that is how you can use the SPC control charts. Then the capability charts, they are also known as process capability analysis. They assess the ability of a process to meet the customer specification. So they basically provide insights into whether a process is capable of producing output within specified tolerance limits. So key points to consider regarding capability charts include it should meet predefined specifications or tolerances. So they provide a snapshot of how well a process performs relative to customer requirements. So now moving into the principles. So capability analysis is based on the principle of calculating indices such as CP, CPK, PP, and PPK. So these compare the spread of process data to the width of specification limits. So a process with CP and CPK values close to 1 indicates a high capability to meet specifications, while values less than 1 suggest potential issues with process performance. Then application. So capability charts are commonly used in industries where meeting customer specifications is critical, such as automotive, aerospace, and healthcare. So remember that capability charts are used in certain industries and SPCs are used in other industries. So when it is more critical, then capability charts are preferred. They also help organizations assess and improve processes to ensure they consistently meet customer requirements. So now we'll go into the comparison. So SPC chart, they primarily focus on monitoring and controlling process variation over time, whereas capability charts, they focus on assessing the ability of the process to meet specification. So that is the difference between SPC and capability charts in businesses. Then real-time monitoring versus snapshot assessment. So SPC control charts provide real-time monitoring of process performance, enabling timely identification of variations. So in contrast, capability charts provide a snapshot assessment of process capability based on historical data. Then we have corrective action versus process improvement. So SPC control charts help identify when a process deviates from its stable state, triggering the need for corrective action to address specific causes of variation. So again, the difference with SPC is that the capability charts, they highlight areas of process improvement, whereas corrective action, which is required in case of SPC. So the capability charts, they are used to enhance overall capacity capability and meet customer specifications consistently. So to summarize, while SPC control charts focus on continuous monitoring and improvement, capability charts provide a quantitative assessment of process capability. So you should keep in mind that both tools are valuable, with SPC aiding in process control and capability charts supporting the process capability analysis and improvement efforts. So that is all for today. We have, so this concludes your module lectures. So we will have another session next week to discuss about the assignments, and that we will also have, basically we'll consider any doubts that you have. So that we will cover in the next session.
Great. Thanks, Andrew.